what can you deploy today? First, we're going to introduce the panel. Maybe you're starting from here. Go ahead, please. Introduce yourself, a quick introduction.
Sure. I'm Baptiste Coudurier. I manage the content platform at Hulu. I'm responsible for ingesting, packaging, encoding, and deliver video streams.
My name is Kevin Streeter, and I run the architecture group for Adobe's Primetime Video Solution platform. I'm responsible for defining integrations between our video players and our ad platform and our publishing backends.
Hi, my name is Jan Nordman. I'm with Fraunhofer in our San Jose office. We do audio codecs, MP3, AAC, and I cover the streaming markets in terms of business development and marketing.
Hello, I'm Carl Ferguson. I'm the head of strategy for the video compression business within the media division of Ericsson.
And I'm Iraj Sodagar. I'm with Microsoft, principal multimedia architect, and been involved in Dash standardizations from very beginning. Thank you very much for coming to these sessions. The format we're gonna do is I talk 3 minutes about the state of Dash today. I ask each panelist to talk at most 6 minutes. They already provided some slides here. And then hopefully we have 20 minutes questions, answers. I hope you ask lots of hard questions. So starting quickly, I just want to give very short overview of where MPEG-DASH is. The standard has been developed by ISO IEC JTC1. The standard name is 23009, and it has 4 different parts. It took something of over 90 experts, 50 companies, 8 meetings a year, maybe 3,000 contributions to develop these standards over a period of 3 years. The first editions of the core standard, part 1, was published in April 2012, and the second editions, which add 2 new features. One is events, and one is MPT publish time. Events is for being able to signal any new events, whether it's media time related or application related, to their clients, something like update the manifest or add entry point is coming up. Or any other type of application-based events can be used. Also, there is a mechanism to signal where the clients can synchronize their clock time with the server. So in terms of having the same clock talks between the servers and client, especially for live broadcast. When the client needs to get to the live edge as close as possible, that feature is important. Features, we're not going to go over the list, but you can see a long list of features. This is not intended for you guys to read. There are several of them, but things that are new in this standards that has not been supported before is, for instance, multiple DRM support using common encryptions. You encrypt your source files, your media files once, and multiple DRMs can be supported with the same manifest. Or multiple CDN supports. The manifest can include multiple base URLs, so a client can go to different CDNs. And in fact, those can be prioritized, which CDN has the highest priority in terms of providing the bandwidth, and that those all can be customized. There is Dash Industry Forum, which takes MPEG-DASH and adds video codecs, audio codecs, closed caption format to it, and also common encryption parameters. Basically makes a complete spec for interoperable deployment. Now, using like implementation like Dash AVC 264s, companies can build solutions that are interoperable at all layers. It has complete protocol stack on it. And there are several activities going on there. There is an implementation guideline to support HEVC. There is AVC 264. There is implementation guideline being worked on for the live services specifically and different scenarios in live services, ad insertions, and so on. And if you look at the state of industry, at least consortia today, you see all these organizations starting from DTG in UK, HD Forum in France and Spain, HBBTV in Europe, DVB in Europe, OpenIPTV, 3G PEP, DLNA, ultraviolet, and ATSC, all adapting Dash as their solution. So if you go in the different markets, Dash is becoming a core specifications for over-top delivery for any of these markets. 3GPP, for instance, for the mobile. W3C is doing 2 specifications, which Jeff talked about today in his panel, and maybe we talk here about how to use media source extensions to HTML5 to be able to do JavaScript-based Dash players, and basically not rely on embedded player anymore on the device. So at this point, I would like to ask Baptiste to talk about Hulu's view and what can we do with Dash today.
Sure. So when we decided to launch Hulu Plus 4 years ago, the market was really fragmented. There were like so many file formats. I mean, Winevine, HDS, HLS, regular MP4, smooth streaming. So it was pretty clear that we had to actually implement them all. There was like no real chance to have like Dash ready. I mean, people were talking about Dash, but that was like 2010, and I mean, it was nowhere to be like usable in production. Also, like it was clear that a lot of formats had issues. For example, smooth streaming required like a server manifest. HLS had to like have audio and video like mixed together. So later, like when we had to launch Chromecast, it was pretty clear that Dash was like the best choice. It actually managed to like become a standard, so we could use a common file format to address like multiple devices, and it was based on like smooth streaming, and it was using MP4 fragmented. So it sounded like really a good choice. And the best part also was that finally we had like something to base our efforts on, especially in terms of DRM. So we could have like only one file and have multiple DRMs on top of it. So it was pretty obvious that it would save us like a lot of cost in terms of storage on the CDN, and it like there was the chance to like reuse a lot of efforts that we spent on a lot of other formats before. Also, like along with Dash came MSE, so media source extension. It's like it enables us to like stream video using HTML5 in the web browser, and actually do adaptive bitrate. So that was like a big innovation. And I mean, the fact that also it was based on smooth streaming actually enabled us to serve smooth streaming to the smooth streaming compatible devices using the Dash files. And that was like really big for us. Obviously, well, during like integration, we encountered a couple of compatibility issues. The first one was like the flavor of like manifest that we're going to be using. We settled on segment-based, but like we know that IE and Microsoft like prefer segment timeline, and segment list is more like the HLS type approach. There was like some issues with HEAC, but I mean that's not particular to Dash, except that I hope that Dash would actually make it clear how to signal HEAC. Cores, there was actually a big deal. Since now you would use stream video within the browser, you needed a browser to actually do cross-origin requests to the CDN, and all the CDNs needed to be like configured correctly to like be compatible with the device, like what type of status code the device was expecting, what kind of content, like the new options request. But well, we'll settle that pretty easily, but it has to keep in mind if you want to deploy Dash in production. Also, and due to cores, we also are a little concerned about HTTPS. If you now embed your player in HTTPS, all the requests, and including the cross-origin requests, have to be made in HTTPS. And as people know, HTTPS costs a lot more to stream than HTTP. That's still we still don't know how that's going to work, but it's a big concern for us. And obviously, I mean, if you want to stream in a browser, you need MSC support to begin with. Google Chrome was really like the pioneer there. I mean, they have full support MSC, EME across all platforms. IE is pretty good, but we're still waiting for Windows 7. Safari, we'll see. And Firefox had great news last week when they announced that they will support MSC. So yeah, I mean, looking forward to innovations there. Hulu is like one of the biggest video online advertisers, so obviously we had to figure out how to provide the best ad experience on all our devices. There are a couple ways of doing it. Right now we're using the double player approach. That is while you're playing the content, we launch another player to play the ad. Obviously that's not the ideal solution, but this was the one that worked for us already on other devices. So we use this one. It is possible to use the segment list approach and have do HLS style ad insertion. Since we preferred using segment-based, we didn't choose that approach, but we really hope that Xlink in the manifest will allow us to actually have the best of both worlds. That's it. That is dynamic ad insertion at the playback. That is when the Xlink is actually loaded, we can provide an ad, so we can really tailor the ad experience exactly when the customer plays the ad, instead of when you generate the manifest, for example. This is going to be very big for us, and we're looking forward to it. So today, Dash definitely a big success for us. I mean, we're serving 100% of traffic on Google Chromecast, Amazon Fire TV, i11 on Windows 8, Google Chrome, and Android 4. We're also serving 100% of the smooth streaming traffic using the same Dash files that we use for the Dash native devices. So we clearly see a lot of storage cost savings. We also, due to that and the fact that a lot of people are actually using these files, we can definitely see an improvement in terms of QoS. I mean, we see between 10 and 15% of rebuffering improvements, and we consider that a big deal. And yeah, obviously general storage cost and operational cost savings. Thank you.
Thank you. Kevin.
All right. Go to the next slide. So I think I just wanted to take my time here to talk a little bit about how we view Dash and how it actually solves a lot of problems that we're trying to work through in terms of being a technology vendor for video players. Really, there's just two things that we need out of a streaming platform, right? We want it to be as simple as possible for us to take video players that we've spent time building, testing, optimizing, and plug them into a publishing system and get content to those players. So simplicity is just super crucial. But the other thing is it needs to also be a platform, something that we can build on top of to do new things, to create new features, to add new capabilities, to make better viewer experiences. And so we see Dash as something that fulfills both of those things. Next. So here's really the problem that we're trying to solve. It's similar to what Baptiste is trying to solve in that we're trying to get to as many video players as possible. But add on top of that, that we also, as a technology vendor, we are trying to make that work with as many publishing systems as possible. And that means that what we have is a big mess. And the reason for that is that even if you look at a single protocol, something like HLS, there's so many variations in how things like content protection work, in how things like closed captioning work, in how things like timed metadata work, that we continue to have to make all of these changes in the video player stack to try to accommodate all of it. And it ends up being really complicated. You end up reinventing the wheel quite a few times. And you really lose your focus on what you want to be doing, which is creating new user experiences and really optimizing, like making the playback as good as possible, making the viewer experience as good as possible. So if you look here, you can really see how MPEG-DASH can help us to clean that up. And it's both the core technology that Iraj talked about, the core formats and the basic systems, but it's also the work that some of these other organizations are doing, the Dash Industry Forum, for example, that is also going to set guidelines for how DRM should be layered on top of the system, which codecs we should use, how closed captioning is going to work. And what that gives us an opportunity to do is really focus on the viewing experience and have a really, really high chance that we're going to interoperate with all of these different publishing backends that are available. So this just kind of explains how we're viewing, at least right now, the mechanisms for reaching all of the different devices that you might want to reach as a publisher today. And it's built around two different protocols. Now, there are certain devices where HLS is the only option and will continue to be the only option for the near term. And so we expect publishers to need to be able to generate HLS content in a way that it can be consumed by our video platform. But for other devices, and we're at a point now where we can reach all of the other devices, Dash is a viable way to do that, where you can actually then have just two streams that are coming out of your publishing backend, and you can reach the entire landscape of devices that you want to reach. And so that's a big change. Right? That earlier slide was a mess. But if you can really say, look, I have two streams, that's a huge improvement over where we're at today. And if we can maintain that, there might still be an opportunity at some point in the future to make that just one stream. So how are we doing this? So this picture is kind of primetime centric. This is how we're doing it at Adobe. But I think you'll see that there are other vendors who are doing similar things. What we have is really two different video stacks. We have one that is a portable video engine that runs on a number of different devices. And this stack will run in Flash. This stack runs on Android. This stack will run on a Roku device, either as a native or either running native applications or with a shim that allows you to write BrightScript. And we also run on a number of different set-top boxes and connected television platforms. So we have a really big footprint with that video engine. And what that means is that we can take our Dash implementation and reach all of those endpoints. Now, on the other hand, there are still some platforms that we don't have our video engine on, in particular the web stack that is powered by media source extensions. And the way we reach that is by using the same content, right, the same stream that is defined by the MPEG standards and the Dash Industry Forum guidelines. But we take advantage of the video engine that's provided by the browser user agent, and we're able to build a compatibility layer with our native players on top of that in JavaScript. And again, we're able to provide this very consistent set of capabilities with a very consistent video quality and video experience across all the platforms. I think that's everything.
Great, thank you. Jan.
Go ahead. That was a shock. Let me go to the next slide, please. Yeah. So just to start off with what's Fraunhofer's expertise in Dash. So first of all, we were part of the development team for the MPEG-DASH standard in MPEG. Just like we've been standardizing audio codecs in the past, this time we worked actively on MPEG-DASH in MPEG and still do until today. And we provide conformance bit streams, for instance, as part of that work. The audio part of Fraunhofer that develops HEA software has a what we call Dash-ready audio encoder that allows you to do seamless audio bitrate switching for a video service if you choose to switch audio bitrates. Fraunhofer is also the team in Berlin, one of the main inventors of the H.264 and now H.265 video codecs. And there's another team in Fraunhofer that does ad insertion and client products for Dash. So we got quite some expertise in that area. This is about the extent that I want to talk about Fraunhofer's work in Dash. The rest of my slides are actually use cases of content providers that use Dash today. So a few of the panelists mentioned it already. Dash streaming to the HTML5 browser is a big promise, but it's actually happening today already. So I call it the past. Maybe it's still today to a certain extent. People use plugins like Flash or Silverlight. But the promise of the future is to have a plugin-free streaming experience to the browser, no matter on what platform the browser is running on. And for that, W3C standardized the media source extension and the encrypted media extension. And on top of that, the APIs allow you to use MPEG-DASH in the browser. In addition to that, well, I would say 4 out of 5 of the leading HTML5 browsers have today native support for H.264 and HEAC, even up to 5.1 multi-channel audio. And, well, we mentioned it, IE and Chrome support Dash already today, so you can use those platforms to serve your content. So in a nutshell, service providers can rely on those W3C standards to serve content securely to the web browser using built-in codecs, using built-in functionality for adaptive streaming, and a completely plugin-free environment. On top of that, I think somebody mentioned it before, Dash Industry Forum was involved in the development of the Dash JavaScript client. I think Jeff Tepper is in the audience back there. He was one of the lead developers, gave a presentation about this earlier today. So this is really an open source client that's available on GitHub that content providers can use and customize to the extent they want to run Dash in the browser. Next slide, please. So this is one recent example of a content provider, a rather big one, that uses MPEG-DASH to stream to the browser. It's the BBC. With everything new the BBC does, they have to do a trial first before they can roll it out commercially. They do a study with that trial that has to prove the consumer benefit of that new technology before they're allowed to spend money on a commercial launch. So that was the first step they did a few weeks ago. And what they did is, traditionally they've been experimenting a lot with surround music. So in this case, they did a live concert that they streamed live to the browser. It was recorded in 4.0. For music, quite a typical surround setup. They used Fraunhofer's AAC encoder at a high bitrate for the best possible quality. And then they just used a BBC internal tool to package the content and deliver it via an Akamai CDN. So the consumer side, in the past when they did trials, they had to make their own players, they had to make plugins. This time they could just use the browser, IE and Chrome for this trial. And they used the Dash Industry Forum Dash JS player and modified it in a way that it supports audio-only streams. And they customized it a little bit for the UI, and that's it. And so the BBC listenership was able to listen to those concerts in surround it live during the event, just using web browser technology. And I've just followed the Twitter feeds about the event and the blog posts they received, and a few people had issues on connecting their PC to a home theater system with an HDMI cable. But except for that, the experiment was a big success because people that knew how to start a browser basically and push a play button were able to listen to that concert in surround, which was quite an enhanced experience for them. So that's the browser. Baptiste mentioned the Chromecast. To my knowledge, it was the first consumer device that came out with built-in Dash support, which also shows Google's commitment for MPEG-DASH. It supports Dash natively. It also supports H.264 video natively and has HEAC 5.1 audio built in natively. So the BBC actually did this internally. They streamed the same content that they streamed to the browser. They streamed that to the Chromecast, and it played in surround just nicely in the living room. You have all kinds of premium content, obviously, on the Chromecast. Netflix, you have Hulu, you have HBO Go, you have now the BBC iPlayer. And, well, Google also says that all the commercial content, video content on the Chromecast has to be in Dash, packaged in Dash. So that was a big success. And now Google Play Movies, as well as Vudu, here in the US, are available in HEAC 5.1 on the Chromecast. So again, the same encoding assets that you would stream to other environments in Dash to the Chromecast. Final slide from me. We've seen the slide of other SDOs that endorse the adoption of MPEG-DASH. This slide in particular is on hybrid TV standards. We've been involved with the work that DVB is doing these days for hybrid TV standards based on Dash. I think the specification is close to being finished. It's in the final stages. And also ATSC decided for the next generation of American TV standards to rely on Dash for the streaming component. And in both cases, Dash Industry Forum is working closely with these SDOs that use the Dash H.264 AVC guideline document that we developed and adapted to their specific use case. So it's always the underlying principle, and then of course it's a TV standard, so every TV standard wants to make their regional optimizations, but it's all based on Dash 264. And in terms of audio, HEAC is mandatory for stereo in Dash 264 and one of the optional surround audio codecs. So broadcasters can use the same codecs for both the broadcast world and the streaming world. It's one of the promises of hybrid TVs. And so also the same decoders that are built into the devices can be used for on-air and stream content. That's it.
Thank you.
And I do have a demo at the end if we have a minute, but we can get to that
Carl?
later.
Okay, thank you. So I'm going to talk briefly about another application where Dash has been used in the future, and that's within Lte Broadcasting. One of the biggest challenges that mobile phone telco operators are facing today is that already video traffic on the mobile phone, cell phone networks is already more than 50% of their overall traffic. And looking forward into the future, there will be a tenfold increase in that amount of traffic on the mobile phone networks. This data is extracted from an Ericsson mobility report. You can go to ericsson.com and download that entire report. It's updated twice per year. Next slide. What the Lte Broadcast system allows operators to do is switch from a unicast delivery mode, unique data sessions to every single handset, into a broadcast mode, and therefore get the benefit of broadcasting the same data, in this case live video, to multiple handsets at the same time. So a vast increase in network efficiency, network utilization, particularly for video services, video information that has been viewed by multiple people across the cell phone network. Next slide. The interest in Lte Broadcast as a technology within the telco operators really covers a number of different applications. The first is for the delivery of live video events. So premium content, particularly in high density areas, so things like 100,000 people being inside a sports stadium or a track circuit for NASCAR or some other event like that. But there are other applications for the multicast side of the technology, which again is quite interesting for telco operators in the future. So things like multicast delivery of cached data. If you were to click on the download later button on your movie provider and then essentially download a movie to your mobile phone or your handset at a later period of time, doing things like updating data and video clips to digital signage and billboards, and also in the future more machine-to-machine interfaces. So, for example, multicasting traffic alerts to all connected cars within a metro city area. So that the general underlying technology here is very interesting for telcos, particularly from a number of different service applications going forward. Next slide. The other interesting thing for telco operators about Lte Broadcast is it's a dynamic service. You can, at either an individual cell network level, a local geographic level, or a national level, essentially dynamically allocate part of the LTE bandwidth to deal with multicast traffic rather than unicast traffic. That can be done from a time dynamic basis, so you can either allocate a period of time during the day that a portion of the network is switched to being multicast capable, which allows operators to essentially dynamically assess the traffic on the network to see if there is a common usage of, say, video assets been carried across the network today as unicast traffic and switch that traffic over to a multicast mode. And the amount of bandwidth allocated to multicast traffic on the cell phone network can be dynamically altered as well to give different quality of service. We'll switch to the next slide. The Lte Broadcast system is ultimately based on a mixture of 3 different standards. EMBMS, standardized in 3GPP, really allows for the ability of the cell phone network to be switched into multicast modes and to allow that dynamic behavior. The system, while there are some early trials that have used H.264, MPEG-4 encoding, but really the direction in the future is to move more towards HEVC encoding to gain the best efficiency across the cell phone network, given that it's a very valuable and extremely limited data delivery pipe. And then MPEG-DASH is the third side here. And the real reason for looking at MPEG-DASH for a standard is, one, it's an open standard, and the second desire here is really that if an operator is using extremely valuable bandwidth to multicast video traffic, then you want to be able to hit the maximum amount of handsets and the maximum amount of browsers going forward as well. So that openness and interoperability is key to enabling this, because really you only want to put one version of that video asset across the network. You can't really support dynamic multi-formatting because you don't have the data capacity in the network. Go to the next slide, please. Thank you. The Lte Broadcast system essentially uses a common sub-profile, a piece of commonality common between MPEG-DASH and 3GP-DASH. So we're using base media file format, the live profile here, so to get some commonality in these standards, and also a few restrictions about what we do from a packaging and video encoding perspective. The video is all encoded with closed GOPs, so a closed group of picture structure for every segment. The video and audio elements of the video service are unmultiplexed. They're separated into individual adaptation sets, and only number-based addressing is used. So essentially it's a subset, a sub-profile of MPEG-DASH and 3GP-DASH that's used for Lte Broadcast. Final slide. And ultimately, Lte Broadcast, and particularly the use of the LTE networks to deliver multicast video services, is heading your way. There have been a number of announcements, particularly around operator trials. Anybody that was here on Monday and listened to Verizon do the keynote speech at the CDN Summit on Monday will have heard them talking about their trials of using LTE network both for content acquisition as well as the trials that they've done using video delivery using Lte Broadcast. AT&T have made announcements of some of their plans here in the US to use some of the frequency they have for Lte Broadcast. And there have been a number of operator trials, particularly around sports stadiums, so essentially enhancing the experience of somebody going to a sports stadium or a race circuit, getting things like multi-camera angles, enhanced video feeds, pit crew camera feeds, all these sorts of different things to enhance the experience, particularly around live sports events. A number of trials have been going on around the world, and the absolute latest was just last week in Holland with KPN, with a number of technology and service providers ultimately enabling those trials. Thank you.
Thank you very much. So we have about 12 minutes to 14 minutes to discuss, to ask questions. Any questions on the floor? Yes, please.
I just have a question on Lte Broadcast. So if you do a broadcast, is there a change on the client side, or the player has to change for that, or is there no changes for the player at all?
So to repeat the question there was on Lte Broadcast. Is there anything about the player or the client that needs to be changed for Lte Broadcast? The early trials have used some beta clients just to basically enable the trials to happen. Some of the early trials also used MPEG-4, H.264 encoding. Some of the later trials have started to now use HEVC. The ultimate ambition here is that there be nothing specific or proprietary about the client side. The delivery of the multicast video across the Lte Broadcast network still gets cached as part of the Dash client side, and in that respect, the multicast video traffic looks no different than any on-demand or segment delivery of an on-demand asset. And one of the key reasons really for using Dash within the Lte Broadcast system was to get to that point of being client agnostic and ultimately handset and device agnostic. If you are the service provider in a stadium, for example, wanting to make money, sell a premium service, sell that experience of getting to a multi-camera angle event, for example, you want it to be completely agnostic to the handset and the client that any of those people in that stadium have got in order to maximize your revenue. So the ideal and the intention and aim here is to be completely agnostic to player.
Okay, first row and then second row, please.
I understand that the Dash, Dash is written to use MPEG-2 transport stream. Are any other protocols supported within the standard, or is it just MPEG-2 transport?
So maybe I repeat the question. The gentleman has understanding that MPEG-DASH support MPEG-2 transport stream. Is there any other transport stream supported by MPEG-DASH? Who wants to take?
Actually, I think if you go back one slide, this slide might help you here. The red box, the outer box here, is in fact the full highlights the full MPEG-DASH profile, and within that you have both MPEG-2 transport main, the piece on the left-hand side. You also have ISO base media file format, the piece on the right-hand side. So in that respect, the full MPEG-DASH profile supports both mechanisms, MPEG transport stream and file format.
I may add that at least -IF and lots of industries are focusing on the blue blocks,
Yep.
the ISO-based media file format, also known as MPEG-4 file format transport, just because it provides separations between audio and video. Therefore, in terms of adaptations, you have much more flexibility, and you can mix an audio and video at the client rather than for every single combinations you have to create mocked transport streams like MPEG-2 plus in terms of the multiple DRM support, in terms of event messaging, in terms of other features, this MPEG-4 file-based system is far more simpler than MPEG-2. I mean, in some cases, it's not even possible to do it in MPEG-2. There was another question?
Yeah, I have a question for Latency. You mentioned that you see a 15% improvement in buffering when switched to use Dash. I'm just wondering how Dash helps to improve that buffering ratio.
Well,
You want to repeat the question?
the question is how can I explain that we see 15% improvement in rebuffering? And well, for multiple reasons. First, the fact that actually so many devices are using the same files definitely helps in terms of CDN delivery, caching, and efficiency. And second point is, since we're using the same player and the same logic and all across the device, it allows us to like really refine the adaptive bitrate algorithm, and we enhance our player to be way more efficient.
15% compared to
10 to 15% compared to HLS.
Good. Questions? Yes.
About this, what's your plan for like Apple devices?
So maybe I repeat the question. What about
what's your plan for like handling Apple devices?
what's your plan for iOS devices? How Dash will be supported on iOS?
Well, we hope Apple decide to support Dash at some point. In the meantime, we still serve HLS. The idea is to actually, if you control your origin, you can rewrap the Dash fragments into HLS on the fly.
Yeah, that's what I was thinking.
Yeah.
Are you looking at that?
Yeah, we're definitely actively looking at that. I hope to have something working in 6 months or something.
Okay.
Yeah.
Maybe I add a little bit to the, I've seen Dash players on iOS devices. It's a matter of getting approved by Apple Store to be provided as a third-party application, not native support. Apparently, Apple does not approve any other format than HLS to be used over mobile networks, whether it's third generations or LTE. On Wi-Fi, they do. So it's not a technical problem. It seems to be a business problem. There was another question here.
And maybe this has all changed in the last few months, but how much of a liability is it to support both MPEG-2 transport stream and MP4 file format? I remember the early version of Chromecast only supported Dash, but only ISO media format. Is that something that we can expect all vendors to support both flavors of Dash?
So the question is there any liability to support both flavors of Dash, MPEG-2 TS based and the profiles that we have, and MPEG-4? Is that the question?
I'll
Yes,
answer that,
please.
Arash. I mean, at least from our perspective, it really just comes down to what are the relative benefits, and what we really want to see is we want to get it down to one format that goes on the wire if possible, and if that's not possible, let's keep it to the smallest possible number of formats. And with the different profiles of Dash, ISO-based media file format versus transport stream, that really is two different pieces of content. It's going to go on the wire differently. So there really has been a lot of alignment in the industry around the ISO-based media file format. One, because there are certain things that are just easier to define within that format, but mainly it's because we really just want to pick one and make that really work well so that we can focus on optimizing the video experiences.
Yes, please.
So just a question in general. From a workflow perspective, does Dash offer any better latency than HLS?
So the question is from workflow point of view, does Dash provide less latency, a smaller latency than HLS? For live or on demand or both? For live. Anybody wants to take that? Yes, please.
I'll field that one as well. So I inherently in just the formats, right, the XML manifest files and video containers, the answer is going to be no. But what is happening in the industry is that because Dash is an open format, there's a lot of innovation that's happening. And one of the things that is conversations that are happening in MPEG, conversations that we have at the Dash Industry Forum is around how do we lower the latency of HTTP streaming in order to give better experiences. And so, it's still very early, but people have working systems. We've built prototypes. I know a lot of other companies have built prototypes where you can get latency down to maybe the size of one segment or less. So I think the opportunity is there. We probably will get there. And it's less about the details of the format, but more about the fact that the industry can actually go and innovate in that direction because it's an open standard.
There is a fundamental constraint as of now is 1 segment duration is the minimum latency in Dash. But you can have very short segments, 1 or 2 seconds. In HLS, usually the practice is 10 seconds. Just by the specification, you can do it, but then it's a matter of also available bandwidth tolerance that the player can play, how much buffering the player can do, early push-ups. So it's one of the hot topics in Dash Industry Forum, as Kevin said, and it's also an impact to how to enable those scenarios, especially for the cases, for instance, Carl said about in-venue live streaming. When you are in the sports arena, people having it, you don't want to have much lag between what people can watch on the handsets versus what's happening. And
because for live, it seems that RTSP still prefer over HLS in some situations. So I'm wondering if Dash provides a better alternative.
for managed networks, of course, RTSP. It's designed to be packet-based delay rather than chunk transfer. But Dash is, or also all HTTPS streamings are, going over existing network infrastructure, not having a managed network, having a full control on the bandwidth to the client and so on.
That's really been a big win for HTTP streaming. Why we sort of have seen it proliferate so rapidly is that the scale that you get is tremendous. And as we've seen consumption of over-the-top content really skyrocket, that scale has been very important. But one of the things that we've definitely lost from things like RTSP or RTMP is the low latency kind of live. And so I think that's probably one of those areas where you're going to see the industry solving some of those problems and regaining that capability here in the near future.
And maybe just to add to that, again, the Dash Industry Forum, as you mentioned, is actively working on these topics. So one way to actually participate in that is to join the Dash IF and work actively in these working groups that deal with live, that deal with ad insertion and so on. Because there basically you have all the vendors that are present in the industry that are trying to collaborate and come up with solutions to address those problems or challenges. So just join and exchange your experiences and provide input. That's the best way to make sure this works in the future the way you want it.
Okay, I would like to add one last thing. MPEG-DASH has way lower override than transport stream. So if you're trying to save costs, it's just a better approach.
Questions? If not, let me ask you the last questions, a little bit provocative one. At the keynote speak today, when the keynote speaker was asked about Dash, he put these slides up. We usually use this cartoon as a joke. So the question I want to ask, is Dash the 15th standard or 16? HLS has 13 version plus the smooth streaming and HDS. Is this just another standard to you, or what's different with Dash that could be the unifying, or is just another standard for people to implement?
I think I don't consider Dash as really a new standard. I mean, it's really based on what was used for a long time. 3GP started with MP4 fragmented, smooth streaming, improved it. Really, Dash is just standardization. It's just making something clear and precise and nothing more.
I think Iraj had a great slide that showed all of the different organizations that are touching Dash and working to try to get a centralized definition of Dash. I think that's really the difference, is that if this was executed poorly, Dash could easily be the 15th standard. But when you have all of these groups that have demonstrated that the industry really does want to align and create something that actually works and actually fulfills that promise of having a single stream that can reach all these devices, that work is going to be what makes Dash a unifier and not make it just yet another standard.
Last points?
I think if anything, it's the only thing that we're using from an Lte Broadcast perspective. I think the other thing we've seen both in this session and actually in the earlier session where this cartoon was put up before is actually that from the workflow perspective, many people are now working in Dash as the core common format when they're getting ready to produce their video assets and video content, and then only translating at the end to what might be needed for essentially the legacy of players and clients that are in the field, but with the 2 to 3 year replacement cycle that's typical for handsets and tablets and many of the common devices that we see in the field, then this effect is only a time transition effect.
Thank you. Thank you very much for participating in the panel. Thank you for coming to the panel.